Yes, thank you for this nice introduction. Thanks for inviting us here. So yes, we are bringing a bit kind of our perspective from this background that was just described, and actually I wanted to start with the Digital Humanism initiative, or a bit of an explanation where this term comes from, and also actually how it also brought us to our collaboration with the Vienna City Library and the City of Vienna. So these things were already said, so I will just give the general introduction. Then Thomas, so he's a PhD student at TU Wien. He will then talk more about the technical stuff. And actually, this digital humanism is now a well-established thing in Vienna. We have a lot of international guests here, so and I will give a bit of the background from our perspective as TU Wien, because there is also a history of this term and activities from the city of Vienna, but I will talk so like from our motivation and our background. And so we working in computer science, informatics, so we see also kind of the role of informatics in society has been kind of changing, and is a very central role right now. So the digital transformation is kind of changing things, and is so important for many innovations, for growth and positive things. But today we really see that it has an impact on nearly everything, and there was this transformation now from decades ago where we had just the isolated personal computer, where now everything is connected. We have Internet of Things, everything is online. It's kind of an operating system of our modern society, which we also saw in COVID crisis, when suddenly, people could not meet anymore, but things worked kind of online, and then everybody had to switch to the virtual world, and not everything worked well, but a lot of things, could be kind of continued. So it's kind of a key technology today, and we also have this hype of artificial intelligence today. So since ChatGPT, everybody is talking about it, and we really also have a discussion between utopia and dystopia. So kind of all the great things that can be done, and others who really see now that once the super intelligence will overtake. And but we see, so the role of computer science has a great impact, and it also affects highly sensitive areas. So this artificial intelligence, this technology, such as medical and health domain, and and only a few people, or not even the computer scientists, so really understand what is happening here, one has to admit. So also kind of the change of models, or how models work. So they are not deterministic anymore, but we have this probability and black boxes. So it's really also a time with a lot of changes and shifts. And then also, and this is a bit from my background in recommender systems, that it was said, so I've been working in this area already for 10 years approximately. And what started 10 years ago with all the Brexit, and also the first time Trump was elected president, was this, it's very sad to talk about this today, but it's already this, the role of social media, or whether they really have an impact on democracy, and also filter bubbles and these negative tendencies. So the question also, what our systems that we develop, how they kind of foster this dynamic, so to say. I mean, it's not only our systems, I mean, it's hard to show, but the question is, to what extent they are really responsible for these negative dynamics, and that there is a correlation is kind of very, it's not questioned anymore. This is a bit of the background why we then, as computer scientists, and especially also here at TU Wien, started to think, what about our role, or so to say, a bit more in depth, and the question is. Also, I mean, here more general for the AI. So, now how can we use this technology? But more general. So this was the Vienna Manifesto on Digital Humanism, which was kind of the outcome of a workshop that was organized 5 years ago at TU Wien, but already together with the city of Vienna, together with the Vienna City Library and a lot of other stakeholders, but it was an interdisciplinary meeting with not only computer scientists and not only Austrians, so it was really also from all over the world, and the idea was a bit to see where we are standing and what are the challenges. And so this Vienna Manifesto, it was kind of a call for action and reaction, and also but a bit of a research program, and it was addressed to science but also to decision makers. And there are only some of them. I think maybe later we will also have a link. But there was some principle statements how technology should look like, but you can see it here. We should try to promote democracy and inclusion. Then software and algorithms should be more fair, responsible, and transparent. So all the these algorithmic things, but then also the questions: what is the role of universities, and what is the role of research? And this manifesto also then kind of defines this term in for us maybe for us computer scientists also in a so to say way how so we see this. So according to our view, digital humanism. So it's about analyzing this complex interplay of technology and humankind, because so we do not only develop algorithms in a technical way, because it has a much broader social and economic impact. The question is to analyze it, but not only to analyze it, the question is also how to influence it, to make better technical systems, more human-centered systems, again for the individuals, but also in this view of so the whole society is affected. And so it's not only about complaining what everything goes wrong, but also really to start to think how it could be different, okay? So this was the background. This was 5 years ago, and I have to say that in Vienna, this is a very well-known workshop and outcome, this manifesto. Many stakeholders know it. It also so we gave the opportunity to sign it. It was translated into different languages. This Digital Humanism initiative is an international initiative right now. And in Vienna, so also this term was kind of also put into governmental programs and declarations. So there are quite a number of those. So politics is quite aware of this. It's even on the EU level, this term, and also some funding programs use kind of this framework now. There are research and funding programs. There is also fellowships. So we have to say in Vienna, we are really going into a broader discussion into this direction. And from us, so there are different books, they are open access, they have now more than 1 million downloads, both books together, these perspectives on digital humanism and introduction to digital humanism. And this is what was mentioned before. We had this UNESCO chair established last year at TU Wien. So this UNESCO chair on digital humanism. It's the only UNESCO chair in a technical university in Austria. And it's also acknowledging from UNESCO these topics have a broader impact. You know, they have now released a few years ago these guidelines for AI and ethics, and now this digital humanism chair also goes into this direction. But what I wanted to say is, and this is maybe not too long, but to give you a bit of a picture why here this term plays a role, and also a bit why we are here actually, because we are established in this regard our connections with the city of Vienna. There is a lot of projects together also with the city library, and we also try of course now to incorporate this in our research. And so this is a bit of the background for what Thomas will now present. And now, yeah, I also give over to him, but so this was the introduction.
So thank you very much. Now we heard our motivation why we are doing what we are doing, and as our talk is called also how we can make use of local knowledge for LLMs, we will now also look a bit into generative AI and how these concepts are impacted by generative AI, because if you look at, I mean, maybe some of you know these Gartner hype cycles, they always bring up every year or even multiple times during a year. And we can see here that this is the hype cycle for artificial intelligence. And we can see here there is like generative AI on the right side after the peak. And but if we think about what's written here, we can see that there are a lot of things which are driven by generative AI. We have, for example, all these, I mean, there are more, but I just want to highlight some of these because we have limited time. All of these things are somehow influenced with these technologies. For example, synthetic data generation is a big topic in our research because you always have the problem if you want to perform research, then you need to have data. But how do you get data? And then sometimes it's suitable to generate data, but this was difficult in the past. Now we have generative AI, we can generate text, but now we have also other problems because now we need to think about hallucination and maybe biases in data and other dimensions which were not there before. And the other thing is also it's just created some new problems because there's, for example, on the left side written prompt engineering. This was something people did not work with before. This is something new which came up with generative AI, we could say, kind of. And also other things like multi-agent systems. It's especially valuable now if you have a generative AI model which can act independently in a multi-agent system. I mean, these technologies were there before, but now it just works better because you can make use of these capabilities to have a system which decides which other component it wants to use based on, let's say, maybe intent recognition of user intents or so. And why there is a second arrow is because for us it's very important to do responsible AI. But yeah, apparently generative AI was faster and is already like over the peak, and responsible AI is the thing which is not so, like it's researched very well by research institutions, but for companies, I mean, this is now only an assumption of mine, but I think there is more money in generative AI than in responsible AI if there is no regulation by the law that it needs to be responsible and kind of. We have some acts now in Europe. There is some things going on in this direction, but yeah, it's something companies only do if they are required to do it. Good, but now we talked a lot about generative AI. I think nearly everyone knows what it is, but we just ask a generative AI what it is. And I think the key aspect here I really want to highlight is that we are here talking about statistical models. It's not some intelligent machine which can like do some logical reasoning. It's in the end just a math model which has learned on a big pile of data and then tries to detect patterns on it and then outputs tokens. Tokens are then just parts of words, and in the end you get a sentence out of it, and you incorporate all the problems you have in our society. You have like ethical challenges, you can have this whole thing with copyright issues because some companies tend to do not release their training data. We do not know what they used for training. Maybe they used some bad quality data which do have some biases, and then we should know it because our system then also incorporates this bias. And these are all things, or like misinformation, or also called sometimes hallucination, if the system just hallucinates something. This is like really a big topic now because we did not have that before. I mean, biases were always there in data and machine learning especially, but now it really comes very apparent because a lot of people are also using it which are not so deep into computer science. And yeah, as we also see, we have, I mean, these are just 3 examples. There is a full array of companies and startups and like enterprises working on producing new models. The first, I just put one of the bigger ones here is like the Gemini model from Google. We have Llama from Meta, previously Facebook, and Qwen, which is, for example, Alibaba Cloud, which is a Chinese company. But fun fact is that Qwen is one of the most open models, and the one from Google is not. I mean, just saying, like they did another way, and also Meta model is more open than the regular proprietary models. I did not put GPT models here because I think you already know them, and we do not need to go into that again. Now we are going a bit more into the technical areas because I assume a lot of you are also out of some engineering disciplines or like working also in the industry sector. And I'm explaining that because we later show our chatbot we developed, and therefore we need to know the frameworks. What we did also in the past was, because we are coming from recommender systems, but recommender systems is also linked with information retrieval. And like information retrieval is if you put something into Google and you get a result back, then this is kind of called information retrieval. Recommender systems is more like you have a user profile, the user does not directly express his intent, and you can recommend something. And then it happens to be that you have something in the middle, which is called conversational recommender systems, and there you have like a chat interface where you can interact with, you can maybe learn some preferences, you can have like a history where you try to understand what the user wants to do. And this is how we came into this research direction here, because this obviously also had a very impact on what we do. Yeah, and what we did was, I mean, these are also just examples. There are a lot of more frameworks, but I think LangChain and Llama Index are the more bigger frameworks to make use of GPT or like any kind of models which work with LLMs. And on the other side, you can see web app frameworks. We used this for our chatbot in the beginning, but apparently now also Shiny migrated their web framework to Python, because previously it was also based on R. R is quite nice if someone wants to do statistical stuff, but not so nice if you want to do data science on it, or at least, let's say, not so well supported by the community. And of course, there are a lot of more apps and frameworks like Django or whatever else there is out there which can be used. And why we did that, and why we also like think that we can use that technology to make better use of local resources is, as we heard before in Digital Humanism, it's very important to have inclusion. You do not want to create barriers, and I think with this generative AI influence, we have now a chance to build something nice. For example, to have a natural language interface which enables all kinds of people to use a system, like not only academic staff which knows this high sophistic, I mean, it's not limited to that, but sometimes papers are written in a very difficult way. And this is maybe not something a young adult can understand, but maybe you want to make this information accessible to these users, because everyone should be able to get all information. And sometimes you also have people with disabilities which maybe cannot write on a keyboard and want to use a voice interface. And all these things are now kind of easier, because with generative AI you can have text input, you can have voice input. I mean, we also had voice input before, but now it kind of works easier and better in many ways. And you can also incorporate any kind of social, linguistic, cultural, and educational backgrounds. And this is now like the user perspective. On the data perspective, we always have this problem that we have heterogeneous data. Like we have kind of images, we have text, we have maybe semi-structured or unstructured data where we just have like a block of text and we want to extract something out of it. In the past, I mean, there are a lot of traditional approaches to extract information, to do some like feature extraction out of texts and to label them. But it happens to be that this now works quite better in many ways. That we can now just restructure text input we get, or we can describe in a very easy way what is visible on an image, for example. I mean, previously people used, it was like computer vision tasks to segment the image, and then you wanted to detect areas and a table on it and so on. And this was like not a very trivial task, and nowadays you can just upload it somewhere and then the LLM tells you what is there. Like, this is not like perfect as for now, but it makes things easier also in research. Yeah, and the other thing is there is currently a lot of money going into this direction, and we can expect very fast progress in this area. And yeah, and what we in the end want to do is, if we have kind of high quality data, like as here from the archive, or if we have resources we have stored somewhere, we want to make them easy accessible, that everyone can just get the information one wants to have. And what we tried out, I think it's already 1 year ago, or is it 1.5? Yeah, I think it's 1 year ago. We tried to just say, okay, let's try that out. I mean, the term for one approach of that is retrieval augmented generation, which is kind of the term how you combine interface with LLM and with local data. And we said, okay, then let's just build a very simple application and put the 2 books we have from Digital Humanism there, and then combine it with a model. In this case, it was GPT, because we wanted to have something. I mean, we did not have at this point in time like a virtual machine with a GPU attached to it, and we wanted to have some like easy accessible service for users. But this could be also any other LLM. And yeah, this worked quite well, and it was like a very nice approach, and it's just like simple embedding based. We will see that later. But this was really the idea: how can we make this information more accessible? And this is also the same we have now for like where we think also there are opportunities for MediaWikis, for example, because on a MediaWiki you have a very big amount of high quality data. You have them, if people use the required plugins, you also have them in a semantic annotated way, and you can really access the data in a structured way. And then we are not anymore only limited to just use chunking and everything, but we will see that on a later slide. We have more options how we can make use of that data. The approach I described before was, I mean, this is now I just took that from one of the frameworks where they very well described how this works. Normally you have a set of data. You try to somehow convert that, like if it's too big, you need to split it up, but sometimes you have also small articles, then it's fine, because a language model normally can only fit a certain amount of text into his context window, and therefore you need to have some strategy to split it up. And then after that, oh, this is nice. After that, you can embed it. This is also what was done last year at this conference, like at that you can make use of a vector store. You do some vectors, and then you can, for example, calculate the similarity between two embeddings, and you can retrieve them to the user. And this is like a very common approach nowadays. I mean, in the beginning it was like, now I think it's quite well supported with frameworks. In the beginning it was more difficult, but now I think we really have some great chances here. And in the end, you have like a vector store with all your articles or chunks of articles. And if then a user does some questions or prompts, the system can retrieve the most similar items and convert them back into like a summarized text and provide it to the user. This is something which is quite well established already. But what we also think about is, I mean, there is more. You cannot, are not only limited to do this embedding-based approach. I mean, if you have structured data, you can also use the text similarity between the text. But what I really want to go into here is you can use query languages for it. For example, I mean, we did some experiments within our lab with generating SQL queries based on databases to retrieve items from a corpora which is too big to just embed everything. And it's a challenge because GPT tends to also, if it is allowed to generate like drop table commands and so on, and change whatever commands. I mean, these are some like things we need to take care of in the beginning. But this is really something interesting, and it works well. And if we have a semantic annotated wiki, one can also make use of knowledge graphs. You can just query the data there if the data are all annotated, and also of course make use of any kind of APIs we have available. I mean, for the MediaWiki, we can also just request the content of an article and like learn the LLM how it can request the content of articles, and then we do not need to store everything locally. Yeah, and just as we said, this approach was also showed last year, and I put the URL here. Yeah, and I think, the time is going very fast. There is more. I mean, there is always more, but there are some more things I want to show because they're interesting. Prompting, for example, can also be done better. Like you can, there is this concept of chain of thoughts where you task the model to think about what it does and to split it up in a kind of a divide and conquer way where you say, okay, please first retrieve the data, now think about what makes sense in this part, and then put it together in the end. And in-context learning here is just another term for that you can give examples how you want to have it, and then the LLM can try to do it in the same way. This sometimes works. It's known that it works better if you provide examples what you want to have, but there is also some research which needs to be done. And now this next one is, I think, a very promising one, but it's also more deep. This is kind of the fine-tuning. This would be, for example, if we say, okay, I have a very big model and I want to tune it on my own data because I want to make a history wiki LLM which incorporates the data of the wiki into, or the behavior of answering into its model. And this can be done with this fine-tuning method, because normally, I think, there are not so many organizations on the planet which can afford to tune a LLM from the ground up. Yeah, and we have also zero-shot prompting, which is just using anything without local data. This is something I wanted to show because I really liked that idea. We saw in the beginning there is this multi-agent systems is one of the emerging topics in these hype cycles. And I think this is really something which will be very valuable in the future, that we can have systems which are like, I mean, we had it also in computer engineering that we have microservices, but if we have a multi-agent system, you can just say, okay, there is every agent is a own LLM itself and can solve some tasks. And you could have, so for example, a front-end LLM agent which takes up the user request, tries to identify the intent of the user, and then uses different approaches of retrieving data from the database or from the vector store, whatever, based on what the user wants to have and what is the best option here. And there are many strategies. I will not go into that one. There are the links. You can just, it's very well described on this page. And there is also the trend that there are now tools where we can just drag and drop stuff and link it together. I mean, I put an example here because they have a very nice picture. But I assume this will be in the future proprietary because they have this kind of phase where it's open source. You can just use it, and at some type of time they need to make money, and then they will close it down. But there will for sure other tools in the future which are open source. Good. These are now the last 2 slides. Yeah. Now let's just think about again what are the opportunities and risks. We heard something about that we have different data retrieval strategies. For example, I mean, this is especially relevant if you think about scalability of your system. If you have a very big knowledge database, maybe you cannot embedding everything, or you need to approach some other strategies, and then maybe a search is the better way to do it. We often also are in an area where we need to host our models ourselves. And then it's quite important what the requirements are regarding GPU power, because it's always easy to put the biggest model onto the problem, but it's maybe not the most sustainable way to do that. And there are also some other things for the users, which is also more in terms with the digital humanism, that we also want to support non-traditional users in end, like users which are maybe blind and need some help, or users who want to have multimodal input or output, and this can also done here. These are 2 risks. One risk, I mean, we know that there is this problem with hallucination. I put it here, it's called BNF grammars. It's a very technical term. In the end, it's just a post filter, and you limit the output of the LLM to a certain allowed set of tokens, which can be done with that. And there is also some tooling support already, because it's apparently a problem that if you tell LLM, please output JSON compatible format. I mean, now for GPT, they have this flag where you can set that is at least compilable, but this is an issue. Yeah, and yeah, I mean, there are some other risks. If there is only a part of the data annotated semantically, you would lose the part if you do a knowledge graph-based approach. Yeah, and we shouldn't forget about the biases. I think this is the most important thing here to say. And one time a professor told me, you should know your biases, because we always have biases. Good. Yeah, to sum up, we had some introduction into digital humanism, into why we do what we do. We heard something about generative AI and how it can improve knowledge bases, and I think it's very important is we should keep the AI in the loop and not the human in the loop. Yeah, we had some practical use cases. We saw some different approaches how we can retrieve data, and an outlook on an emerging topic. And in the end, we highlighted some challenges and opportunities. Thank you very much. Sorry for taking over time.
No problem. This is a very interesting topic, and I really enjoyed the presentation, so thank you for that. I'd like to know more about, you mentioned about like embeddings and vectors and stuff like that. Thanks for going back to that. Yes. What was the process of that? So you have to train it every single time that the content is updated?
Yeah, this is a very good question. This approach does not require retraining of the model. What you do is, I mean, what also was presented last year is you would create an embedding of an article every time it is deleted, created, or updated. I mean, if it's deleted, you just remove it from the vector database, but you need to update the embeddings as soon as the data change.
How long does it take to create the embeddings for each article?
Creating embeddings is very fast. It also depends on which model you use for the embeddings, because there you can use a different model than you use for the LLM. But this is not the problem. I think this is quite easy to do, because as long as the data do not change, you do not invalidate them. You can just keep them in a vector store.
Yeah, that's great. So sorry, but I would like to go more. What is fast? I'd like some concrete numbers, please. Because this election went by really fast, but
okay, the
10
thing
hours is not fast for this.
Yeah, but the thing is, embedding of your data store is done as a batch process normally. Like you do it once in the beginning, and then you just update the deltas. But you also need to embed your search queries, and this is normally done, I would say, in milliseconds. But I mean, this depends, or I mean, it depends also on your GPU resources. If you are doing the embeddings only on a CPU, on a web server somewhere, how you scale it. I mean, if you have, I think we saw 300K users using the platform. If everyone uses it at the same point in time, then you will have some load on that, yeah.
Okay, and then my last question is, have you tested the efficiency of a vector embeddings-based solution compared to an RAG-based solution?
Yeah, this is the same. Retrieval augmented generation is kind of using the embeddings for retrieving the data.
I'm not sure if I agree with that, but okay.
No, you have an LLM, and you ask a question. The LLM embeds the data, and then does a vector similarity search based on a vector store and retrieves the most fitting items, and then brings back the text of it, because you know the link between the embedding and the text of the item, and summarizes that and presents it to the user.
There are multiple approaches to RAG.
Yeah, of course, yeah.
Okay, I'm talking about more generic RAG.
Okay.
It looks like that's the approach you took, and if it's the same results, then cool, good to know. Thanks.
Yes, thanks a lot for the presentation, and thanks a lot for bringing up exactly this slide, because I have a connected question to it. So you mentioned that as your first try, you did embeddings and chunking on your 2 books, which are open access, which I think is great anyway. And so what I presented is that we also do chunking, but do chunking, I would say, intelligently, with subheadings and so on. So if you have a book, traditionally, you have nice structured knowledge. So how did you do the chunking? Did you do some brute force thinking, or did you split up the headings?
This is a very good question. I think I tried out all the variants in the past.
Okay.
The thing is, we also wanted to have the reference to the page where it was on, that we know on which page it was written. Because what works best for us was a recursive strategy to retrieve the chunks. And for that we could use the ebook version of the book, because there you
standards and
but then you lose the information where the text was located on. You cannot say, okay, this is on page 5 or so.
Which is not a problem if you use wikis and hypertext. But related to chunking, I heard that the long chain chunker, for instance, it takes brute force 1,500 characters and some overlap, and that's it. And don't care about these crazy humans using section headings and crafting out the headings and so on. Did you try a chunking where you split at the headings?
Yes. Very good example here. Our problem was once that we had some wrongly retrieved embeddings, because the header and the footer is always writing the name of Digital Humanism, and then there are this. If you just employ basic OCR, or you translate into text, you end up with these problems. Or if the heading goes over 2 pages, and then you have half on one page, half on the other page. We tried out a lot of different ways how to make it work.
I want to go deep down the rabbit hole, but maybe we can get into context.
Yeah.
Because I'm exactly digging into this, and I don't have all this 80% problems with how much AI before you.
But I think I think there is also an anecdote, right? Because first this chunking, one person tried it and then he wanted to find himself, but then he was not there as an editor because of the chunking.
yeah. And then we got like a reply that we need to look into that. And
the problem if she or he is high ranked, right?
Yeah, especially if she or he is the first on the author list in the book.
No, but it started as a summer school project actually, so this was the excuse.
Yeah.
Thank you very much.
Okay, thank you. Yeah.